This video is about the reflection required practical for the physics topic 6 waves. Okay, so what do you need? You need a ray box with a slit, you need a power pack, you need a ruler, a mirror, a protractor and a piece of paper and a pencil. I'm using a pen so that you can see it clearly when I draw it. Okay, so the first thing we need to do is set the experiment up. So the power pack is plugged in at the mains. I will then plug in the ray box. It doesn't matter if it is connected to a DC or an AC supply, you can use either one. And I'll take the slit out for you for now so you can see the difference. So if we turn it on, make sure the voltage is nice and high so that you have a bright light to work with. The slit, if you put it close to the light source, you get a fuzzier line than if it goes further away. So put the slit in the furthest part from the bulb. So now we have a nice sharp line to work with. Okay, so to start off with, you need to draw a line on your piece of paper. So let's start with a nice straight line. You must use a ruler all the time for this. That line is your gauge so that you know where to put your mirror. Your mirror needs to be aligned perfectly with that line. So the face of the mirror is along that line that you have drawn. Make sure it's not set back. If you set it back, then you won't get reflection perfectly on that line. So make sure the mirror is properly on that line. Okay, so once you've got that, you can position your ray box. So I'm going to come in at an angle like this. Okay, you can clearly see the light is coming in, it's hitting the mirror, it is reflecting off and it is coming out this way. So to draw that, we need to put a little marker here, can't see it, little marker there, a little marker where it hits the mirror, another one coming out, and then another one down here. What we can then do is remove the apparatus and join those lines up. Make sure your line that you're drawing goes right back to the line that you've drawn for your mirror. Okay, perfect. All right, so next thing you need to do is you need to measure the angle of incidence and the angle of reflection. So just for completeness, if we put arrows on the ray diagram to show the incident ray and the reflective ray. So next we need to draw our normal. If you remember, the normal is the imaginary line that is at 90 degrees to the boundary. So for accuracy, we can draw that using our protractor. So set it up with the middle here. So 90 degrees along your boundary, mark down there. Okay, so you always draw your normal as a dotted line because it is imaginary, it is not a real line. So that gives us our normal down here, okay? So it's not 100% accurate, but it's close enough. Okay, so next we need to identify what angles we are looking at. So we've got this one here, and we've got this one here. So this is your angle of incidence, this is your angle of reflection. So let's do it down here, where should we do it? Over here. So using your protractor, as I've said, you need to measure from the normal, not from the boundary. The mistake people make is they measure from here. That's not right. You need to measure from the normal. So align your protractor along the normal. Okay, let's go this way. Let's start with the angle of incidence. So the angle of incidence, you can see I've got it lined up 90, 0. So reading the outside, because we are starting here, we're going this way. So we're looking at 10, 20, 30, 40, 45, 46. Well, it's really 46.5 degrees. Flip the protractor. Align it again. So with your 0 and 90. This time we're using the inner one, not quite lined there. Use the inner one because we're starting at 0, 10, 20, 30, 40, And here we're up at 45, 46, 47.5. Okay, so the law of reflection states that the angle of incidence should equal the angle of reflection. As you can see we are 1 degree out, but if you look closely there, you can see I'm not 100% there with my drawing. Okay, so that will account for that extra degree that we have got in the reflected ray. So what I'm going to do, I'm going to do one more to see whether I can get slightly more accurate reading. So I'm going to realign my mirror along that line. I'm going to bring in my ray box and I'm going to change my angle of incidence this time. So I'm going to go for a bigger angle. But you can see I'm using the same normal. I want to use the same normal. So I'm going to come in here, reflect here, come off here and out here. So same process. Remove those, just turn that off for now. Okay, so let's draw it up here. In the right place, yeah, that's in the right place. Out here. Oops, keep paper. Just come down here. Okay, so we have our angle of incident ray and our reflected ray. So we have a new angle of incidence, which is this one, and a new angle of reflection, which is this one. So straight to the protractor along the normal, making sure it's perfectly aligned 90 and 0. We're using the outer scale here, so 10, 20, 30, 40, 50, 60, and that is 61 degrees. So if I draw a line here, we've got a 61 degrees, this angle of incidence. And then over here, fingers crossed for another 61. So it's all perfectly aligned. 10, 20, 30, 40, 50, 60, 61 degrees. And there you have it. So you can see the difference, because if you look here, this is meeting the mirror perfectly this time. Okay, and that allows for the angle of incidence and the angle of reflection to be equal. And there you have it, your required practical for reflection in the waves topic.